Hello everyone, welcome to another session in the data structure series. This is the sixth session. So today we will discuss about graph representation. In our previous session, we had mentioned that there are two ways. One is the adjacent matrix and one is the adjacent list. So today we'll go into a little bit deeper into them. Before we get into these two representation, just a summary on what we had discussed previously. What is a graph? A graph is basically a representation of a data structure which has got nodes or vertices, okay, and it has got edges. So, like we had mentioned, these are the nodes, and the connection between two nodes is called edges. Okay, and there are basically four types we had discussed: undirected, directed, weighted, and unweighted. These are the four types we had discussed, and we had discussed about where are the real world scenarios or examples of it. So those were uh, social media, and the other was the roadmaps. Okay, so yeah, this is just a brief, just so that it's a refresher for you on what we had discussed previously. Now let us come to the example that we want to understand today, that is on adjacent matrix. Okay, so let us say this is a graph. So in this graph there are four vertices. So let us say v is equal to uh, 0 1 2 and 3, and there are edges. Let us say there is an edge between 0 to 1, 0 1. There is one more between 0 to 2, 0 to 1 to 2, and 2 to 3. Okay, so these are the vertices and edges that are there in this graph. Now how are they represented in matrix? Let me take a different color. So matrix is basically a v cross v. So v cross v matrix. Okay, so what does that mean? So it is a 4 4. So it is a 4 cross 4 matrix is how this whole graph will be represented. Okay, now let us get into the details. So I'll delete these numbers because we have the diagram to see, and here I will represent it. So 4 cross 4, let us say 0 1 2 3, and 0 1 2 3. So this is how you would have seen a 2D matrix also, that is similar to that. Now if it is there is a connection between the two edges, then it is represented as 1, and if there is no connection, then it is represented as 0. So 0 0 is always 0. Now we have got a 0 to 1, right? That will put it as 1. So 0 to 1 and 1 to 0 are both initialized in the same way. So 1 0 and 0 to 1 same. Similarly 0 and 2, there is 1, and 2 and 0 would also fall on the same category. Now 2 and 3, so 2 3 and 3 2, and then we have 1 2 1 2 2 1. So these are the ones which are connected. The others are just zeros because they are not connected. So this is how a graph is represented in the form of a matrix. So here what do you understand? In this the connection between two edges A and B, the relationship is A and B as well as B and A in this matrix. Now a little bit around complexity. So time complexity in this is coming up to O of vertices square, because irrespective of how many vertices and all are there, you are representing them into v cross v. Okay, v cross v, so that is basically a v square. But the good part here is how you fetch the data. So the fetching of the data here is very easy. So the time complexity to get in data is O of 1, because you just go and get the matrix of, let us say if this is the matrix A, then A of 0 comma 1, you will immediately get the value. So this is basically for weighted or to check the connections as well. Got it? So hope this gives you a good representation of how a matrix is represented for a graph. Let us move into a adjacent list. Okay, so list, as the name suggests, it is going to be represented in a form of a list. Okay, let me just remove everything. Okay, so how does it gets represented is in the form of list. So let us say O 1 2 3. So what are the uh, edges that are connecting to 0? That is 1 and 2. So in this it will be represented as 1 comma 2. So 1 is connected to which two? 0 and 2. So 0 and 2. Similarly 2 is connecting to 1 and 3 and 0. So it should be actually 0 1. Let me just erase it. It should be 0 1 3, and 3 is represented under 2 or connected to 2. So yeah, very simple. Basically it is showcased as a list. So here the space complexity is O of v plus e. Okay, because it takes vertices and the number of edges into it. And what are the various use cases where you can use these two graphs? I think that's a question I would like to put up to you. So let us say there is a use case where you have to represent a social network graph with millions of users in it. Which of these two, matrix or the list, would you use? If you know the answer, please comment it in this section. So hope this gave you a good oversight on the two representation of graph methodologies. Thank you for your time. Please do check the other sessions that we have created for data structure, and have a good day, and please subscribe.